Good morning, everyone, and welcome to the webinar on cloud computing getting started. First of all, I would like to thank everyone for finding time in their busy schedule to attend the seminar. Hope you all are doing fine and wish you a good health. You can type your questions in the chat box during the webinar is in progress, and I'll take all the questions at the end of the webinar. If there is any miss, we'll respond it over the email. So rest assured for that. At the end of the webinar, there will be a feedback form that will be sent across. We'll post it into the chat window as well as it will be sent across in the email. Just fill in the feedback form, and you should receive the certificate of participation. So let's get started. So these are the topics that I would be covering, in today's webinar. It is what is cloud, where did it started from, and what is, how it is reached till today. Who are the different vendors who are providing the services, the types of clouds, the types of services that they provide, what is server, what is serverless, how secure is the cloud, what is the impact of the cloud in general to the businesses, where is the cloud industry leading, where is it going now, and next thing is how it will impact you, why you should you care about it, and if you are interested, then where you can start from, what you should do basically. Okay, so let's move on to the first thing. What is cloud? Okay, let's put it in a very simple way. It is just like it's a humongous computer of somebody else that you want to use over internet on a temporary basis, in a very oversimplified definition that I can put it to anybody to understand. Okay, so this computer that you are accessing over the internet has a lot of storage capacity, kind of an unlimited storage capacity, unlimited memory, which is RAM, unlimited processing power. Whatever you want to do, you can do it with it, because you cannot own such kind of a resource. You can just connect to it and use it uh, for your at your disposal for whatever time you want, and you just pay for whatever you use. Okay, that's as simple as that. So it's not just a normal computer that we are talking about, which has the storage and computing. It has a lot more than that. It has a lot of capability. It has a capability like artificial intelligence services, machine learning services, voice services, translation services, big data services, deep learning services, it's analytics services. There's a lot of it's a spectrum of things that is provided by these services. Okay, and the idea is actually not new. Okay, the idea kind of existed from the invention of internet when we started. That brings me to the next topic, which is like the origin of cloud. So the idea of the cloud, basically the concept of cloud, or the design of cloud basically existed since the time when the internet was designed in ARPANET in 1960s, where they tried to communicate using two computers over a network. Okay, they showed the network as a cloud in their diagrams. Okay, and which they didn't know like how the network would be. It was a vague thing which actually resembles to the actual cloud, right? If you see the actual cloud, it doesn't have a form, it doesn't have a shape, it doesn't have a size, but it doesn't matter actually, right? Until unless it rains and we get water, it's all good. So similarly, until unless the cloud form, like until unless the cloud serve the purpose, we are not bothered as a user or as an end user. We are not bothered the size and shape and things of the cloud. Okay, then why did this cloud ever existed? I'll take an electricity. Now we have an electricity provider, okay, maybe Tata Power or maybe MACB, who is providing you. So these are companies which are providing you electricity, right? The electricity basically can also be generated by yourself, that you can use. So you can use a generator, buy an expensive generator, use some fuels to fuel it up and generate energy, and you can use it at your home, right? But normally people don't do it, right? Reason behind is it's very costly, it's high maintenance, and it will cost me too much. Then it's easier for me to just subscribe to an electricity company, and then I'll just pay the bills, which is simple, right? And which is cheaper. So uh, that's where the cloud has come into. Okay, initial days of internet, if you remember, you have to set up your own servers, physical servers. You have to buy all the hardwares, make sure that your machine is 100% 24/7 powered. There is no outages. Make sure that it is connected to the internet every time, right? And also the physical security, the network security, everything has to be taken care by you, right? The first initial cut, early days of internet when we talk about. Then the data centers came up. You have outsourced the power requirement, the internet connectivity requirement, the physical security of your machine to these data centers, and they take care of it. And what you do is you just sign a contract with them saying that, okay, I would need one server of this capacity and to use. But the problem was you have to have a large contract, cost at the initial stage itself. So say I would say at least you should be having a contract of a year. Okay. So a year of contract for a server has to be done with the data center so that you can own a server. Then we came up with grid computing. It's like sharing the resources that were just lying down, or that were not being used in the ideal time, and clubbing all those things into a virtualized environment, and providing it as a server to somebody. Okay, but that didn't work out very well. But somehow by the time AWS come up with the cloud services in 2006. So from 1960 to 2006, this is a journey that we see of cloud. And then the cloud has realized and was made generally available in to the public, okay, in 2006. And that's where it says caught up. So AWS was the first player in the market, and that gave him the upper hand. And that's where he has the 90% 90% market share. Okay. And then that brings me to the vendors, right? We're talking about the vendors. So then we have Microsoft, which is Microsoft Azure, which is catching up with Amazon, which has a 5% of the market share as of now. And then we have other players, Google, IBM, Adobe, Oracle, and other lot of players that we have, Alibaba and DigitalOcean. There are a lot of small players as well, and all of these combined become the rest 5% of the market share. Okay, so I would rather say that it is a two participant race. Okay, of course, Amazon is a clear winner in that, but Microsoft is catching up. Okay, and Google, from a futuristic perspective, Google looks promising because the services that they are using, or they are building, or they are providing right now is something which is a futuristic services, and they are doing it way ahead of time, which is they are providing artificial intelligence, machine learning, deep learning, big data, analytics, and these kind of services. So those are like way time ahead. So even Google looks promising now. Okay. Then when I move to the type of cloud and the services of cloud. Okay. So in the types of cloud, if you see, the first type that I see here is the public cloud. So the public cloud is basically a normal general availability cloud service which anyone like you and me can subscribe to and use it as and when I want. Okay, as and when we want. So it's just like filling up a simple form, like we did for the registration for this webinar. Just fill in the form and a registration form, and that's it. You are in, and you can use whatever services you want. You would need a credit card to sign up, by the way, but you won't be charged upfront. And you can use your services, and they would be charged based on the usage of the services. Most of the services that are there are free, so you might not have to pay anything ever at a personal level. At an enterprise or a business level, definitely, because the volume is too high, so you might have to pay. But at the personal level, you might not have to pay. Even if it is have to pay, it's very minimal. And that's how you can just use and build things up on the cloud. Okay. The second type is a private cloud. Now, the private cloud is basically having an enterprise or a company having its own data center. Okay, they don't, because there are some processes, some data which is very secret, and it cannot be disclosed to the public, and that's the reason they want to keep it into their own data centers. Okay, making it more secure, and only the people whom they want to be have access to that data centers. So that's basically the private cloud. Now, private cloud setup comes up, like the data center comes up with some virtualization setup. It's like Mesosphere, DCOS, and VMware, vSphere. So these are the applications that you can install in your data center that gives the user of the private cloud an access to create virtual machines, or storages, file servers, database servers, whatever you want to, right? You can just virtualize the whole environment, and you can build things up on whatever you want to build. Okay. The next type of cloud is basically the hybrid cloud. So the hybrid cloud is a combination of the public and the private cloud. So basically, you can say some of the data is more critical and I don't want to share it, so I can keep the data and processes in my own data center. But most of them are, are not that critical, and then I can push it into the public cloud and in general availability. So what happens is the public cloud is much cheaper. Okay, and setting up something for yourself as a data center is too costly. Okay, so you can keep the critical data in a costly data center, which is your private, and you can control that, and you can push the general data and processes and applications into your public cloud. And to me, this is the general arrangement that most of the clients also have. Okay, they want to keep their secure data into their own private data center, or they want to have it into their own on-prem applications servers, and then they want the rest of the things to move on to the public cloud. Then the next thing that have recently come up is the community cloud. Now, the community cloud is basically a collaborative effort in which the infrastructure is shared between several organizations from a specific community. So say, for example, a banking community, or a travel industry community, or maybe a healthcare community. Okay, taking that community into consideration, they share the infrastructure, and because they have a common concerns, right, and common setup. So the security would be specific, the security would be common for the banking applications, or the compliance, the jurisdictions, and all those things will be common for these kind of industry. So that's where the community cloud has come up. The number of users for the community cloud would definitely be more than the private cloud, but very much less than the public cloud. So that's kind of an in-between thing. Okay. Now, these are the types of cloud that we have seen. Let's move on and see what are the types, what are the services this cloud, what are the category of services, I would say. It's not services, it's just a category of services. So if you see, it's a huge list of services that this cloud service provider provides, but these are just a simple category of services, I would say, we are just seeing there. So the first one is infrastructure as a service. So when we say infrastructure, it's like the physical infrastructure, the machine, the hard disk, the RAM, the processor, the operating system. Okay. So providing this as a service, which means you can create or spin up a server in no time. Okay. You can just fill up a form which says, okay, I want this, this much GB of RAM, this much GB of hard disk, and this is the processing speed I would need, and this is the operating system. Say, for example, I just want a Windows machine server, which is, say, for example, having 16 GB of RAM and maybe 2 TB of hard disk, and maybe octa-core processor. I just specify the form, fill the form, and this then just submit, and my machine is ready. My machine is ready so that I can use it. It's as simple as that. You don't need to physically buy out things, punch in the RAM, build the whole server on yourself. It is just, and it takes a few minutes to have your server ready. It's as simple as that. Okay, and once you are done, you can just shut off the server, and that's it. So you will only pay for the time that you're using the server, and you will not be charged beyond that. Okay, it's just renting out the it's as simple as renting out the physical server for a few minutes or hours, and as per your need. It's on demand. Okay, and the operating system that is given to you, it's like specific for your disposal. It is not shared with anybody else. Okay, so that's how company can save a lot of cost there by sharing the resources. Okay, it's like pay per use model or pay as you go model kind of thing. Okay, the next one is basically the platform as a service. In platform as a service, I am just worried about my code. I just write a code in whatever language I am comfortable or my developers are comfortable with to provide the functionality and service to my customer, and then I just give it to the cloud service provider saying that, hey, take this code and run it whenever my customer asks you to. Okay, that's it. So the underlying structure, the underlying uh, requirement of the setup of the web server or any of the servers that is required, the load balancer, the hard disk requirement, the processor, the RAM requirements, whatever requirements is there, right? Or the operating system requirements, everything will be taken care of by the cloud service provider, and you don't need really to worry about anything else. What you need to worry about is your code correctly written to solve the purpose. That's it. That's basically platform as a service. Some of the services that you have is elastic beanstalk. Now you won't understand that's a service provided by AWS, which basically does this. Okay, similarly Azure also has really strong platform as a services where you can just push in your code and things will be taken care of by the Azure environment. Okay, then you have software as a service. Now, software as a service has been there for some time now. One example that we see is the Gmail, okay, which is a mail client over the web, and you can see and do a lot of activities with your mail, send mails, do a archive mails, delete mails, and all those things. So these are the functionality normally provided by a web client, but that is given as a service. Similarly, there are a lot of other, you have Google Docs, Google Slides. Similarly, you have Office 365, which is all online, which is on cloud, which is a software as a service. Similarly, there are a lot of other applications, right, which is available as a service, a software as a service, which you can just use it. You don't need to build on things. You don't need to configure anything. Just take the product and use it. As simple as that. Okay, rest all thing is taken care by the provider, the service provider, like all the network availability, the machine, the application should be always available to you whenever you want to look at it. So say for example you want to have your Gmail access, it should be always there for you, 24/7. You cannot say I cannot just log into my Gmail account, I cannot see my mails. Oh, that's not possible. Okay, so that shouldn't be that shouldn't be the case any given point of time. Then we have function as a service. Now, this is again very interesting and very recent thing that has come up, which is companies like companies have exposed their APIs as a service. Okay, so they create APIs which are which can be reused to build something else, some other applications. So they just write a function. So I can say API is nothing but a function which is written in any of the language. We don't need to worry about what language it is implemented and all. Okay, and you can just use the function. Okay, and build your own application. For example, I can just say, this is basically a microservice architecture, not a monolithic architecture. So when you build an application using microservice architecture, these functions that you use serves as the microservices, and you plug in those microservices in your application and you build your application. Okay, one example that I can give is from the payment. So in India we have a UPI, right? UPI is unified payment API interface, sorry, your unified payment interface. Now, unified payment interface is an interface that has been the standards have been defined by government, and all the banks IT department has implemented these APIs. Now, these APIs are exposed to the different apps, right? The Paytm app, phone pay app, free charge app. You can take any of these app, right? These app are basically using this API to connect to your bank account and authorize you and use do all the debit and credit transactions. You can accept money, you can give money to somebody. So that's basically function as an interface. Okay, sorry, function as a service. So function or API as a service is already being used in a lot of areas. Okay, so these are the types of services that the cloud service provider provides you. Okay, now let's move on and see what's server versus serverless. So when you say server, you can, it's just a powerful computer that you have that you can have an access. It is all rack mounted flat computers. Okay, so it's not like your machine that you have at your home or like a laptop that you have here. Okay, it's just rack mounted, which has processors and RAMs and hard disks. That's it. They don't have monitors. Okay, so these are servers. You can just see at the right hand side, there are some examples of the racks where the servers are kept, right? Then next one is serverless. Now serverless is just a concept. Okay, the concept is that you have to not think about, or you don't have to think about a physical machine when you basically build your application. Okay, it's abstracted. So what you need to do is you worry about your functionality, you worry about your code, you worry about your data, and all the underlying requirements of machine, how the machine would be and how it would scale up or scale down. Okay, that will be taken care by the service provider. Okay, so you just give the code to the service provider, and it takes care of the thing. So say for example, you build an application. Okay, the application will need a database. I will not have a server where I will go and install my MySQL or SQL Server database. I'll just go and create a database by on the Amazon, which is like maybe Redshift or something. Okay, where I can just go ahead and create a database and use it. Now, where is this database, which server it is, and what is the space what it has been using, and do I need to give more memory to it, do I need to give more hard disk space to it? That is not my concern. Okay, that will be taken care of by the service provider. Okay, so that's kind of serverless. So if my application uses database, I can go and create a database. If my application need a code which will connect to the database and write it, I'll write a lambda function, or Azure function to it, which will connect to the database and do some activities. So again, these functions are on its own. You don't need to have a server to deploy these things. So that's where the whole paradigm shift is happening. So the application that you're building, say for example, you're building a mobile application or a web application. So consider you have building a mobile application. You build a mobile application, you put it into your Play Store. The Play Store application will connect to your Lambda function and will get some data from the database. Now here, neither Play Store you are worried about the server, neither in the Lambda function you are worried about the server, that where is the server, how much space and how to manage it. Neither in the database you are worried about the server. Okay, so there is no server at all. So that's where the paradigm shift is happening. Okay, so the future of development would be a serverless computing and serverless application. Now let's move on to the security thing. I can say it's more secure than it was earlier in the early days. Around 15 years from now, slowly and gradually, the public cloud has become more secure. Definitely, there are different categories to it. Uh, there are some government clouds and all those things as well. So security, is always a shared responsibility, as I say. So just to give an example, if you consider that this example of NHS, National Health Service from UK, that got hacked for with the WannaCry ransomware, where it was asking for the Bitcoin, money in Bitcoins, where it encrypted all the files. Now the reason for that attack was, or the hack was basically, uh, the IT department missed to update some softwares. Okay, some software or security patches were not installed, right? So now when the when we see like these cloud service providers, Amazons and Googles and Microsoft, they will take care of all the patches, and it won't be just for you. It will be for everybody. All the, because it's a shared environment, right? So all the security patches, all the software updates, everything will be available for everybody. Okay, you don't need to worry about updating the software or the security patches or making sure about the security is enough. From the physical security perspective. Now, as I said, security is a shared security model. So, where they can take care of about the security from whatever they can control. Okay. But some part of it is from the user perspective as well. As I give an example always, that I have a Google Drive, I have a folder in a Google Drive. And if I make the Google Drive folder as shareable, okay, it is shared and it is open for anybody, but somehow I put some sensitive information in that drive, okay, then I am at the fault. So the security breach is done by me as a user, not the cloud service provider. So it's always a shared security model. And as I always say, security is not a product. It cannot be a product. Okay, it has to be a process. So before putting anything onto the web or before putting anything anywhere, I need to think about the security aspect of it. Okay, and that's where security will always go hand in hand with the provider and the user together. um, then we'll see what impact does cloud have on businesses. So definitely business have an upper hand now because they have an infinite compute and infinite storage machine that they can directly go and use, and they don't have to pay anything upfront. Okay, where there were time where they have to buy out hardware and set up the whole IT infrastructure, and it takes months and months to set it up so that they can start doing anything. Whereas this cloud computing has enabled them to do it on day one without worrying about any infrastructural issues, and they don't have to pay it. It's just pay per use model. So what they have to do is just use it, and whatever they use, they just pay for it at the end of the month. Okay. So cloud is also redefining the roles in IT. So the IT, the hardware engineer or the infrastructure guys, okay, infrastructure roles, where they used to work with machines day in day out. Now there are no machines. Now there are no physical machines. Okay, as a user, as a business IT infrastructure guy, there are no machines. If you are working with AWS, it is all code. So if you need a RAM, you need to write a piece of configurations or a script. If you need upgrade the hard disk, you need to do some configuration changes. You don't have to really take a hard disk and plug it in, right? So that's where the role is also changing. You need to be more aware and about the cloud so that you can solve the purpose of the business from the IT role perspective. Okay, and because of this, business has got time to focus more on the value proposition. So basically, you will focus on creating more value to the customer. You will be worried about how my business can give more value to the customer within the same price point. Okay, and you would not worry about the infrastructural issues. Okay, and also you can try on doing on experiments. The business can go and do some experiments with the new values, new services that they want to give. And at the end of the day, they don't need to worry about the collateral damage, because if they have to set up a whole server for a particular experiment, and if the experiment fails, they are left with the server which they don't know what to do. So at the end of the day, they are left with that collateral damage. But considering this fact that in cloud computing, you once you shut it off, it will be used by somebody else, and you just pay for whatever you have used. You are left with no collateral damage for that. Next, we can say where, let's see where the industry is heading. Okay, industry is heading. So you can see there are like there's just a 10% penetration of cloud in the industry. Okay, penetration then in the sense there are only 10% customers or businesses that has moved on to cloud or completely moved on to cloud. There are 90% businesses still evaluating and looking out for how they can fit into this cloud era, and how they can move their things into cloud. Most of them are not able to do it because of the lack of skills. So either the person who are evaluating lack the skills, or after evaluation they don't have the manpower to implement those things, right? That's where you have a huge demand of cloud professionals, cloud developers, architects, and administrators, and all those things that is there in the market, and there is not enough supply. Okay, so uh, I would say that when for any industry, okay, if you use the cloud in a right way, it would be much cheaper, easily scalable, and the company has to with zero downtime, and the company has to has to pay zero upfront money at upfront, anything at the start. So if you can design it in a good way. Also in the development front, the cloud native applications are getting more popular nowadays. The serverless applications are getting more popular nowadays, as compared to the monolithic application that we used to build. Okay. Next, let's look at why should you care about cloud? What it has for you. So I would say it would become an essential service like internet. Like internet in today's day, right? With this COVID situation, we understand that internet become the essential service now. Okay, you cannot live without internet. And similarly, this is going to happen that you cannot live without cloud. The internet cannot live without cloud. Most of the applications and services that we are using day in, day out today, okay, are all based on cloud. So considering that internet is there, but cloud is not there, so cloud service providers is not there, so none of this service is going to work for you. Okay, so cloud is so the whole world is moving towards cloud slowly and steadily. It was never built for cloud, but yeah, it's slowly getting transformed and migrated to cloud. Okay, and we are the part of the journey. So you need to be aware about what exactly is cloud, and how it works and all, because in an industry which is completely driven by cloud now, and slowly getting transformed into cloud, if you don't if you're not aware about it, you would become irrelevant to the industry. Okay, and also from the business's perspective, no business can survive without moving on to cloud, because if your competitor is moving into cloud and getting benefit out of it, he can pass on the benefit to the customer, give more value to the customer with the cheaper price. And if you have to compete with the same price point, you have to go to the cloud, or else there is no way you can beat the price point. Okay, and most of the time, nowadays companies are becoming a technology company first and the core industry next. So basically they have to have a technology driven approach towards doing anything into their business. Okay, and when I say how would you be impacted, of course you would play any of these three roles going ahead. Like either you could be the end user, that you are now, that you're using an application which is based on cloud, and you become an end user, or you become a cloud user, which is basically like a developer who is building an application for the cloud, architect who is designing application for the cloud, building something using cloud. Or you can be the cloud provider. Basically you work for Amazon, Google, or any of these cloud providers, and build the hardware, the infrastructure, the services that will be given to the users. Okay, so it can be in of the any of the roles. Okay, but you cannot live without it. You have to have, we all will be a part of a cloud uh, ecosystem, in some days, or rather I would say we are already. Now, next thing is how do you want to get started? So the first thing I would say, if you want to get started, if you want to help, if you want to help, first you need to get help yourself, decide on what you want to do and how do you want to go ahead. Because I can say it's not very easy. Okay, it is difficult. Because it's a complete paradigm shift that we have been doing for a decade now, more than a decade now. Okay, but it'll take some time, but don't give up. I would definitely say don't give up. It will eventually be, it'll eventually you'll get there. Okay, And there are a lot of materials, resources, people, contents available that you can really spend some time on and get things for yourself. Most of them are free as well, but right, free things comes with a quality compromise. But even if you have to pay, it's not a very high amount that you would pay. Okay, it'll be a nominal amount, and it'll be definitely value for money that you would pay. And you can definitely start with the major players, Amazon and Azure. Okay, they are the market leaders, and the demand for these kind of professionals are too high in the market. You can definitely start with Amazon, and or Azure. If you're a Microsoft fan, you can go ahead with Azure. Okay, and try to get the certification, because I really urge you to do the certification, because even if you do the basic certifications, okay, go ahead with Amazon's practitioners, Amazon certified practitioner, or AWS certified practitioner, I would say, or go with Azure fundamentals, Microsoft Azure fundamental certification. Now, by the time you're preparing for the certifications, you would get to know all the fundamentals of the cloud computing by these providers. And during the journey of the study, you would you would know that what you would like, and then make sure you go ahead and do that specialization that you want to. It could be maybe big data specialization, it could be IoT specialization, it could be security specialization, it could be any specialization, an architect specialization, it could be any other specialization that you want. Okay, but I think the first thing of the key takeaway is go ahead and do some certifications of any of these clouds, mainly Amazon and Azure and Google, so the basic fundamental cloud providers. Do this so that you are aware about it, and you would be able to talk the same language that the cloud professional is going to talk about. Okay, and you wouldn't be relevant to the industry. uh, so if you need any help or something like that, anybody of us is available. Okay, you can just get in touch with us. And yeah, that's it, I guess. That's it I have. Thank you very much. Thank you very much for your time.